So we're going to talk about the third form. We've talked about how to graph in standard form, given standard form, how to graph given vertex form, and the translations. Now we're going to look at what's called factored form, or sometimes called x-intercept form. And this is what we hope to accomplish: writing a quadratic equation, given a graph, given the solutions. Okay, so that's what we're going to accomplish today. Let's just review for a second. So the vertex, let's mark them as we go. Here's the vertex, and that is the point 1, 4. My y-intercept right here, that is the point 0, 3. My axis of symmetry goes right through the vertex. We're going to need to remember that. So that's x equals 1. My x-intercepts, that would be -1 and 3. And if I would write those as an ordered pair, that would be the point -1, 0 and 3, 0. So here are they as written as ordered pairs. Here is it as set notation, because remember, these are the solutions. These are the x-intercepts. Okay? So remember, your x-intercepts are your solution. Now we're going to write a vertex form. A vertex. Oh, actually, A here is 1. I know that because I'm going just 1 apart over here. So I know A is 1. I'm going to end up 1, 2 over 1, 2, 3, 4. So this is a parent function just turned upside down and shifted. But A is just 1, so we don't have to worry about a stretch or a shrink. So vertex form, remember, is x minus the x-coordinate, quantity squared, plus the y-coordinate. So my x-coordinate, my vertex is 1, so x minus 1 quantity squared, plus 4. So using my vertex, I can plug it in. Remember vertex form, y is equal to x minus h quantity squared plus k. And h, you always have to plug in. You want it to be a minus sign. Okay, so factored form can also be called x-intercept form. Remember when we factored quadratic equations? So when we had equations factored, we would have like x minus 2 and x plus 5 is equal to y. And in order to solve, we had to take both of those and set them equal to 0. Well, that's what you've got to remember with x-intercepts. In order to get 2 and 5, we had to have it be the opposite. That x-intercept is always going to be an opposite thing. So this is factored form. A is just like always. If it's negative, it opens down. Positive, it opens up. If it's a fraction, it's going to be wide. If it's a whole number, it's going to be narrow. That's the same. P and Q are listed as the x-intercepts. So this is one x-intercept. This is the other. It doesn't matter which one's which. Okay, so we're going to write a factored form. That's really important you understand. I'm going to write a factored form because we're not going to worry about a right now, although it is 1. Oh, hello, we just wrote that. So, I'm sorry, this is the same equation. We're just now going to write it in factored form. So we're going to take this graph, all of our information up here. So here are my x-intercepts. So y is equal to x minus my x-intercept times x minus my x-intercept. Now, we're not going to leave it that way. We're not going to have minus and negative. So the equation in factored form is x plus 1, x minus 3. That's what it looks like in factored form. So given the x-intercepts, given the graph, we can write it in factored form. Okay? Pretty easy. Now, you're going to write the equation. But you're going to use that 1/2 is a. Write the equation. Pause yours right now and write that equation in factored form. Go. So your x-intercepts are -2, 0, and 3, 0. So y is equal to x minus 1 of mine, -2, x minus the other one. So for our final, and we have to put in 1/2. So 1/2 times x plus 2, x minus 3. Now, we haven't spent a lot of time with A, but you can see how here's your vertex right here, okay? And the vertex is always halfway in between, so my vertex would be about right. Here's my axis of symmetry, right there, because it's halfway in between. My vertex is halfway in between. We're going to use that in just a second. Okay, now we're just going to be given the x-intercepts or given the solutions, and we're going to have to write the equation. And we're going to write a quadratic equation. You can use anything you want to for the letter A. So A can be equal to whatever you choose because this is one of many. So what I'm saying here is that I'm going to write it in factors form assuming A is 1. So y is equal to x minus 4 times x minus 7. That is an example of one. We could also write y is equal to 3 times x minus 4 times x minus 7. This could also be a quadratic equation for this information. Because we don't know anything more, you can write y equals, and I know some of you smart alecks might, y is equal to 100 times x minus 4, x minus 7. If all I ask for is a quadratic equation, you have several options. So now, if those are my solutions, those are my x-intercepts. So again, y is equal to x minus negative 5, x minus negative 9. So y is equal to x plus 5, x plus 9. Put anything in. There's one example, so there's an answer. These are all answers for the particular problems. Okay. We could also have y is equal to 14, x plus 5, x plus 9. These are all answers to that particular problem. Okay, you try, go. Okay, so on this one, did you have y is equal to x minus 2, x minus negative 7, so you cleaned it up, and y is equal to x minus 2, x plus 7? There's an answer. And then you can put anything you want to in for a, and you are right. Okay? So that is, given information, we can write the equation. Now we're going to be given the equation. We have to come up with the graph. So we're going to start off by plotting our x-intercepts. So plot the x-intercepts. So notice that in factored form, it's always y is equal to x minus p, x minus q. So we want a 0. That means my x-intercepts are 2 and 4. So 2 and 4. Now, we're going to find the axis of symmetry next, because the axis of symmetry is halfway between the x-intercepts. So halfway in between is 3. Can you see that? Let's make it in 2 colors. There's my axis of symmetry. That is my axis of symmetry. Remember, the axis of symmetry gives you the x-coordinate of the... so you could also say that the x-coordinate of vertex is also the same as the axis of symmetry. So the axis of symmetry is halfway in between. The x-coordinate of the vertex is halfway between. So for my vertex, my x-coordinate of my vertex is 3. My axis of symmetry, x equals 3. Notice that those match up. That's on purpose. That's not a coincidence. That's truly on purpose. That's the way it's always going to work. Now, to find the y-coordinate of the axis, the vertex, plug in x coordinate and solve for y. So we have y equals x minus 2, x minus 4. So I'm going to plug in what x is equal to. So I can't put an x there. X is 3. So I get 1 times negative 1. Therefore, my y-intercept, y-coordinate of my vertex is negative 1. Okay, so here's the point. Here's my vertex. And I can graph it. And it's going to go up like this. Okay. I could write this in vertex form, can I? Though, over 1. That's because that's going... No, we're not going to worry about that. So we just have a form of this equation. Okay. So here we go with another one. And if you want to, pause it and try it on your own. So this tells me my x-intercepts are negative 2 and negative 1. My axis of symmetry is going to be halfway in between that. So x is equal to negative 1 and 1/2. It's going to go right here. Look at that. It's going to go right there. Halfway in between. That's my axis of symmetry. Okay. This one's opening up. I made them all open up. So let's find the vertex. So far, we know the vertex is negative 1 and 1/2. we're going to have to take that. Okay, see everything that I did halfway in between my x-intercepts is my axis of symmetry. It's also the x-coordinate of my vertex. So now I'm going to take that and plug it in. Y is equal to x plus 2. Look at my mistake, people. Good. So did you find my mistake? Look right here. X minus 1. That means this is not a negative 1. That's a positive 1. So all my stuff is wrong. And look what happens. Nothing. I just erase it and make the correction. So now, here we go. Let's see what we're still going to have a fun one. Not quite as fun, but, well, almost. Okay, so halfway in between. And I do this. You're supposed to add them up and divide by 2. Look, just use your fingers. Bam. Now I'm going to go halfway in between that. Yes, I could add them up, divide by 2, and I'd still get the same thing. So it's actually negative 1/2. See that? Because I went in 1, that's the same. Halfway in between, I go in until I can't go any further, and that's going to be halfway. What I'm supposed to do is take negative 2 plus 1 divided by 2. So that's negative 1 divided by 2, which is, of course, negative 1/2. So that's how I do it mathematically. I take my 2 intercepts, add them together, and divide by 2. I use my fingers. Okay, so now we're going to do that with the equation, the correct one. So that's a negative 1/2 here, negative 1/2 there. That gives me 1 1/2 times negative 1 1/2. Okay, I know this is ridiculous, but I'm going to use my calculator to make sure I actually do it right. And I get a negative 2.25. Negative 2. Are these in fourths? Oh, how nice is that? 1/4, 2/4, 3/4. Nope. There's 5 marks in between, so that's 1, 2, 3, 4, 5. So it's not in fourths. That would have been way easier. So negative 2, and this is going to be 1/4. These are 1/5, 1/5, 2/5, 3/5, 4/5. Yep. So I have to kind of guess. 1/4. Here's halfway, about right there. Okay, there's our vertex. So what is our vertex? Negative 2 and 1/4. If you have this as negative 0.5 and negative 2.25, that's the same answer. That's your vertex. So now we can graph that. Now we could find the y-intercept too. We're not going to right now. We'd have to multiply it out. Blah, 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 blah. Okay, we're just going to sketch it from that. Okay, one more. Go. You try it. I'm going to give you a hint. You might want to sketch it. It makes it a little easier. I'll do it both with sketching and mathematical, but sketching it might be helpful. So here's my sketch so far. I plotted my x-intercepts. I then moved my fingers, and I came up with that my axis of symmetry is x equals 1. Therefore, that's also my x-coordinate of my vertex. Now, in order to find the y-coordinate of the vertex, you've already plugged it in probably. Y is equal to 1 minus 3, 1 plus 1. So I get negative 2 times 2. I get negative 4. So negative 4, 1, 2, 3, 4. This would be my, hello. But I have to put that here on my axis of symmetry. And here's my graph. Okay, but there's my vertex. Good. Let's look at the homework. The homework, it gives it to you in factored form. It wants you to open up or down, axis of symmetry, vertex. Is it wide or narrow? Does it translate? Domain and range. We haven't really dealt with domain and range. If we had lots of time, maybe we'd get back to that, okay? Same thing on these. You're going to be doing the same thing we just did. So let's do one that opens differently, okay? So I'm going to jump all the way down to number 6. Then I might go up and pick up that other one too. Okay, so here we go. Let's plot our x-axis. So our x-axis are 3 and 9. 1, 2, 3, and 9. 4, 5, 6, 7, 8, 9. There's our x-intercepts. Is this, okay, and look, notice what this does. This one opens down. Opens down. So if it opens down, that means that I have a maximum. because it's going to go like this. It's going to open down. Let's find that axis of symmetry. So halfway in between, right there. That's my axis of symmetry. And that's the point 1, 2, 3, 4, 5, 6. So my axis of symmetry, x equals 6. So I know the x-coordinate of my vertex is 6. Let's go find the y by plugging it in. So, and they did it in function form, which is kind of nice, because then you can show I'm finding f of 6. Don't forget that negative. So it's going to be 9. So our vertex is way up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. There's my vertex. It doesn't go wide or narrow because A is 1. Translates to the, let's see. So my vertex went over and it went up. So it translates to the right and it translated up. What did it translate up? It translated 1, 2, 3, 4, 5, 6. So it went over 6 to the right. And it went up 9. We already knew that. Up 9. Okay. So if we wanted to write the vertex form of that one, we could do that too. So this is our graph. It's kind of narrow, it seems like, but it's not. Because A is 1, so it's just kind of normal. Vertex form would be y is equal to x minus 6 quantity squared plus 9. No parenthesis needed. Okay, good. Okay, great. Thank you. If you have questions, you know where to find us.